Welcome in Dark Core. Our universe is a vast and mighty place, but like everything else in this world, it has its expiration date. Scientists have long been discovering ways in which our universe could stop existing. And we have several guesses on how this could happen, but one of them is specifically odd because the culprit in this instance is emptiness. How do particles appear and vanish from nowhere? What makes emptiness not really empty? And how can vacuum, in a blink of an eye, put an end to everything we know? Every now and then scientists discover new scenarios that could lead to the destruction of the universe. Our world could freeze, rip apart, and even collapse in on itself. But it could also just end in a quantum vacuum decay. Similar to how boiled water transforms into gas or turns into a solid state when it's cooled, almost everything in our universe has its states and transition phases. And it is the stability of the universe or stability of the quantum vacuum that keeps our world together. But let's start from the beginning. What's the tiniest thing that you can think of? An atom? You wouldn't notice it with the naked eye, but does this mean atoms are mostly empty space? Any matter consists of atoms, so it would also mean everything is empty space, and that's not the case. We're just used to seeing this world on a larger scale. When we need to know how big something is, we just measure it. For non-quantum objects, it will always work as different ways of measuring an object will result in the same calculations. But for the smallest objects of all, like single atoms, none of this will work. This is because according to the quantum field theory, we live in a quantum universe where particles cannot be explained using classical physics. In classical physics, something can behave either as a particle or a wave. In quantum mechanics, though, particles are a strange combination of both and their exact position or speed cannot be predicted with precision. This is called the uncertainty principle. One big misconception is that the primary object in physics is a particle. In reality, it's the field, the fundamental building block of the universe. Quarks, leptons, and bosons are elementary particles. Everything in our universe is made of them. And every elementary particle has its field. All the matter in this world is made of quarks and leptons. Bosons, however, that consist of gluons and quarks, create force fields or invisible glue that binds things together. So even if something seems empty, it's not. Dark energy, quantum fluctuations, and the Higgs field will always be there. And because of that, there's also mass and energy. So vacuum doesn't mean something empty but something with a minimal amount of energy instead. To understand how this works, you need to rethink the concept of energy. Each particle contains quantum energy, different levels of energy. And an absence of energy would also mean an absence of particles, or the vacuum state. In reality, however, we cannot have zero energy. There would always be a small amount of it in the form of gentle quantum field vibrations. And sometimes, as a result of these vibrations and even the slightest output of energy, particles could be formed. And because such particles only form in particle and antiparticle pairs, they quickly annihilate each other and disappear. But why does it happen? Everything in this world aims to get rid of energy and reach a ground state. Atoms combine to form molecules to lower the overall energy of the system, and even physical objects want to lose their potential energy. A ball that sits on top of a hill has a lot of potential energy, but once it gets down a hill, it loses that energy. Something similar happens with particles. As they give off their energy, they freeze in a state of vacuum. Physicists believe there are two types of vacuum. True vacuum is a stable, lowest energy state possible. False vacuum only pretends to be true but still has a lot of energy to get rid of. And some scientists think we might just live in such a universe. They call it a metastable universe, meaning it could be easily thrown off balance. And all this is because of one particularly interesting particle, the Higgs boson or the God particle. So what's so intriguing about it? Scientists have long been trying to discover and study it. But once they've proven the existence of the Higgs boson and measured it, they have also stumbled across its strange properties. Because of the particle's mass, there's a possibility that the God particle has not yet reached its vacuum state and is rather metastable. Why is that so important? As long as the quantum fields that make particles are in a vacuum state, the universe is stable. This is because a vacuum state cannot lose more energy than it already did. The Higgs boson and its Higgs field are what make things have their mass. And this is crucial for the way particles interact. So if the Higgs boson is in a false vacuum state and it somehow transitions to a true vacuum state, the whole world and all modern physics will change. Scientists believe the particle is stuck at a particular energy level. So it only seems to be stable, and it could still have tons of energy to lose. The problem is the Higgs boson functions as a base for all matter that exists in our universe. Living in such a universe imposes certain threats. If something goes wrong, the universe may just eliminate itself. And there are two ways this can happen. The first one is to somehow create a powerful energy event. The second way is through the effect called quantum tunneling. Scientists believe that because of random quantum fluctuations, a particle can go through an energy barrier without having to overcome it, similar to how radio waves can travel through walls. In case scientists are right about the metastability of our universe, the Higgs field can descend to its true vacuum and cause vacuum decay. But what exactly would happen? And should we be scared? As soon as just one Higgs boson reaches its true vacuum state, all the other Higgs bosons will follow its lead. This would resemble a domino effect, creating a huge bubble of vacuum decay, the walls of which would expand in all directions at the speed of light. And as it passes through space, it would swallow everything on its way, and all matter and forces known to us would stop working the way they do. The basic structure of matter could obtain a significantly modified form. And although the walls of this bubble might carry a tremendous amount of energy that would burn human tissue and bones, there would be no pain. People wouldn't even see it coming. We'd be gone in an instant. Once planets and stars are swallowed, entire galaxies would drift apart. Atoms would no longer be able to hold themselves together. Whatever new form the universe obtains, it would hardly resemble the place we once inhabited. But if this event takes place at the distant corner of our universe, it may never reach us, as the universe is also expanding, and, on a cosmic scale, the speed of light isn't that fast. This phenomenon cannot be foreseen. So it could happen anytime if it hasn't already. We still don't know if we can make the Higgs boson descend to its true vacuum. Stephen Hawking thought that the energy levels of the God particle could be affected experimentally, but that would be very hard to do. It would take about 100 million tera-electron volts. To compare, the Large Hadron Collider generates collisions at an energy of 13 tera-electron volts, 1 TeV equals 1 trillion electron volts. So, to throw the Higgs boson off balance, we'd probably need the Large Hadron Collider the size of our planet. So far, anything that happens afterward is a total mystery. Scientists have no idea what it would be like to live in a world built around new physics. We don't know what particles could be there, how they would interact, how chemicals would react, or if life would be even possible in the first place. But as soon as we find out, we'll make sure to let you know about it, so stay tuned. Thanks for watching Dark Core.